This is Principles of Ecosystem Ecology, Chapter 12, Temporal Dynamics. Ecosystem processes constantly adjust to temporal variation in environment over all timescales. This chapter will examine how ecosystems change over time and the time course of responses of the ecosystem to different events. Ecosystems are always changing in response to past changes as well as responding to current environment. What's important with this chapter is to understand that understanding the present requires understanding the past. So when we look at an ecosystem today, the structure and the function of that ecosystem is dependent in part on the current conditions, but it's also dependent in part on past conditions. And we have to understand both the past conditions and present conditions to understand current form and function. In addition, understanding the past helps us predict the future. So if we're taking a look at a process, for example, and this is time on the x-axis, say something like years, and the y-axis might be something like NPP, then we can see that there might be a decline in that function. From a predictive standpoint, if this is modern, we might go forward and say that it might stay at that same rate or continue to decline. But if we could reconstruct the past, we might see that this is actually part of a larger cycle. So it's important to take a look at what past events have been and how those ecosystems respond to those past events in order to better understand what the current condition is and predict into the future about how things might change. For a focal issue, the authors state that people have altered ecosystems more rapidly and extensively in the last 50 years than in any comparable time in human history. The things we've been doing to ecosystems over the past 50 years really do eclipse anything that's happened before. That being said, some of what we see in ecosystems today is a result of things that had happened before the past 50 years too. But if we take a look at what has been happening, we know that there's an exponentially rising human population, and this won't continue on forever. At some point it's going to level off or decline, but there are a lot more humans than there were before. And also our consumption of resources has increased exponentially, and there's ever increasing technological capacity, which allows us to interact with the environment in different ways than before. The most urgent need in ecosystem ecology is to improve our understanding of factors governing resilience and change in ecological systems. So this is a relatively new term that we haven't used before, and one of the foci of the current chapter, and that's resilience. And essentially, resilience is the capacity of an ecosystem to sustain its fundamental function, structure, and feedbacks in the face of a spectrum of shocks and perturbations. These are all relatively new terms that we've talked about, but what resilience essentially is the ability in the face of, if we take a look at over time, is it to maintain that function, and if it is perturbed, to go back to the original function. So the two different components of resilience, or what we want to think about for ecosystems, is their ability to resist changes in the environment or disturbances, for example, but also recover. So we're thinking about resistance and recovery. There's a number of changes that have happened to ecosystems as far as their state factors are concerned and the interactive controls. Figure 12.1 highlights some of the climate-induced warming responses of ecosystems, and essentially the increase in fire frequency and severity that many ecosystems have experienced. Some of the focal questions that they offer: how do ecosystems respond to disturbances that they often encounter? So disturbances are a natural part of the time course of ecosystems. And many of the species that we find have adaptations, for example, to particular disturbances, if not rely on disturbances for their life cycles. So disturbances were once thought of as being exogenous to an ecosystem, but to be honest, there are many disturbances that could be relatively well integrated into the dynamics of ecosystems. So first thing is to understand, if we have disturbances that happen and they're often encountered in an ecosystem, what is the response as far as different ecosystem processes are concerned to these disturbances that are often encountered? In contrast to that, we want to think about how ecosystems respond to novel disturbances. There are things that we're doing today, for example, that have not been encountered very often by species in those ecosystems before. And it's just as important to think about these novel disturbances as those disturbances that are less novel. Lastly, what properties of ecosystems enhance their capacity to sustain their structure and functioning in response to changing disturbance regimes? So what is it about an ecosystem, for example, that if we were to compare two ecosystems, and there might be an event that happens here, one that allows it to maintain its ecosystem function over time, but another one that might change its ecosystem function. So what is it about an ecosystem that allows it to resist an environmental disturbance, or change to another state, or even thirdly, respond but then recover? So these are the types of questions that we have when we're thinking about resilience and the temporal dynamics of ecosystems.